Oops, what did I do? There we go. Okay, let's take a look. So what are we going to do here? Let's talk about this. So you look through your reasons. Now, how is it that we prove lines are parallel?
They're coplanar, do not intersect.
Okay, they're coplanar and do not intersect. How do we show, I mean, what's the only thing we've ever talked about in this class, though, a way to show that lines are parallel?
Arrows.
Say it again?
Arrows.
Okay, well, arrows is how we would indicate it on a picture. What I mean by that, though, maybe I'm not making my point here. If I want to show that I've just got two lines, and I want to somehow prove that they're parallel, probably what else do I need here? A transversal, yeah. If I have a transversal also, I had some ways to show that the lines are parallel, right? What's one way, given that if I have a transversal crossing two lines, what's one way that I could prove that the lines are parallel? What's an angle relationship that would show that they're parallel? Okay, so if, for example, if alternate interior angles were congruent, then that would tell me that the lines are parallel, right? Now, if you look, if you go to the chapter 3 stuff on that list of reasons, right, if you pull up that document, you'll notice when you get to the chapter 3 stuff, there's going to be kind of a group of relationships that start off by saying, if two parallel lines are cut by a transversal, right? There's a whole bunch of them, and we're familiar with those. We would know that if parallel lines are cut by a transversal, if we know the lines are parallel, then we know that the alternate interior angles are congruent, or that the corresponding angles are congruent, or that consecutive interior angles are supplementary, stuff like that, right? But that's not what we're doing here. In this situation, we're trying to show that the lines, or prove that the lines are parallel. So that group of statements doesn't really do us any good, because they all start off with the assumption that we already know the lines are parallel. But if you go right below those, you'll see a bunch of converses that fit the pattern that we need, right? Those are the ones that all say at the end, then the lines are parallel, right? Those are the ones that start off by saying, for example, if corresponding angles are congruent, then the lines are parallel. If consecutive interior angles are supplementary, then the lines are parallel. Or in this case, if alternate interior angles are congruent, then we know that the lines are parallel, right? So going back to our picture, then if we want to show that these segments are parallel, what might we need to do?
Extend A.
Okay, so we could extend, well, like one of these segments, right? We could extend maybe this one, how about? Okay, and so if I want to show that these lines are parallel, what angles would I maybe need to first prove are congruent in order to prove that the lines are parallel? What angles would need to be congruent?
T.
Angle, okay, good, there we go. So we could say like angle T and angle M. Very good, because those are alternate interiors, aren't they? If this is my transversal, they're alternate because they're on opposite sides of the transversal, and they're interior because they're between the two lines, right? Does that make sense? So when we're planning this proof, that's something that we probably want to be, if we could just show that angle M is congruent to angle T, if we could show that somehow, we got it made, right? Then we know the lines are parallel by alternate interior angles, converse, right? So that's the trick. We've got to get to that point where we can show that those angles are congruent. Okay, how can we do that? That's kind of the trick here. let's see what we've got. Okay, how could we do that? We got to get to show that that angle is congruent to that angle. Well, what information are we given here? Really not that much. All we're given is that A is the midpoint of segment MT and A is the midpoint of segment SR. What does it mean to be a midpoint? In the middle. That's really it, isn't it? The midpoint tells us that it's the middle of the segment. And so what does a midpoint do to a segment? It divides it up into two congruent segments, doesn't it? Right? So that, even though it doesn't seem like we're given a lot, we can turn that into something better. What does it mean that A is the midpoint of segment MT? What could I say because of that? A is the midpoint of segment MT. So what? Big deal. What's that do for us? Tyler, what's that do for us? If A is the midpoint of segment MT. If it's in the middle, what's it doing? What do you think, Karen?
Is it the midpoint for R?
It is. It's also the midpoint for RS. So we'll put that up here too. But let's just focus on the green for just a second. If A is the midpoint of MT, everybody go back to kind of probably page 1 or 2. What do you find about a midpoint? Any statement on there about a midpoint on your list of reasons? Anybody find anything interesting about a midpoint? What's the definition of midpoint say? Read that off, please.
Midpoint of a segment bisects the segment into two congruent segments.
Definition of midpoint says a midpoint bisects the segment into two congruent segments. Okay, so what's that tell me, Alec? What's that tell me then about this green segment? If A is the midpoint of MT, so what? Okay, make sure, I know you got the Chromebook, but you're gonna have to be able to do this. So everybody stop, if you got other stuff, you're trying to get stuff done, don't do it now. Focus on what we're doing here. I need some help with this. Tyler, back to you. So I bet you can answer the question now. So by the definition of a midpoint, what does this midpoint do to segment MT?
It breaks into two pieces.
Into two congruent pieces.
Yeah.
So can I add some congruence marks up here?
Yeah.
What could I do? Like
Yeah.
there and there. Good. Okay, good. By definition of midpoint.
S and R.
And then S and R can do the same thing, right? I should be able to say that this one is congruent to that one. Okay, that's good. We're getting a start. I've got some stuff up here. Any other obvious congruencies up here that we could add? Trinity, do you see anything else up here that's obvious? Do we have any congruent angles, for example? What do you see?
Angles that are.
So tell me where do I want to put my pen? What angles are you talking about? Right, okay, right in here. What do we call those angles? Vertical angles, good. So we've got this angle and that angle are congruent by vertical angle theorem, right? All vertical angles are congruent. Okay, so now let's kind of think about this big picture for a second. We've added a bunch of little congruencies. Our goal eventually is we want to show that that angle is congruent to that angle, right? Think what we did in section 4 or 5. We added a new trick. In section 4 or 5, we said, okay, we've got all these fancy ways to show that triangles are congruent. SAS, SSS, etc., right? If we can show that two triangles are congruent, that's useful because then we know that all 6 parts of one triangle have to be congruent to all 6 corresponding parts of the other triangle, right? Are there some triangles up here that it might be useful to show are congruent? And think about this, kind of think ahead here. If we could show that some triangles are congruent, would angle M and angle T be corresponding parts of those triangles? Because if they are, we could use that new step CPCTC, right? That's all that's saying is corresponding parts of congruent triangles have to be congruent. Any suggestion about some triangles that it might be useful to show are congruent? Kristen, what do you think?
MAS is congruent to RAT by SAS.
Okay, so how about the left triangle and the right triangle being congruent by, what's the pattern going to be? Side, angle, side, right? Side, angle, side. As I walk around the outside, that's the order of the congruencies on both sides. Side, then an angle, then a side, congruent to a side, then an angle, then a side. Now, I got to be very careful with this congruency, or this triangle congruence relationship, though. What are we going to call? Well, Kristen called this one MAS. So, what's the other triangle? Martin, what does the other triangle have to be called if this one is MAS? And be real careful with this. This is a little tricky. Okay, RAT. So, you want to change it?
No, I mean, yes, but you can do it.
Okay, so it's not going to be RAT. What does it have to be? TAR. How come? Okay, because remember, when we write a triangle congruence relationship like this, we have to make sure that that the order of the angles is just right so that they match up, right? The corresponding ones match up. Why is angle M, why does that correspond to angle T?
Because they're alternate interior angles.
Okay, well, maybe because they're alternate interior, but if I look at this triangle, if I just focus on the left triangle, how would you describe angle M? Well, angle M would be the angle that's pinched between the side with one dash and the side with no dashes, right? Well, what's that look like over here? The angle between one dash and no dashes would be T, right? So they have to match up. Angle A is pinched between one and two dashes in both triangles, right? Then that leaves angle S is between no dashes and two dashes in both, right? So that'd be R in the right triangle, or the one on the right side, I should say, right? Does that make sense? Okay, so if that's true, and you already told me that that's true by SAS, then how can I show that angle M is congruent to angle T? I already know that now the triangles are congruent. So M matches up with T, doesn't it? So how can I show that? Angle M is congruent to angle T by what? Justin, by what?
Alternate interior angles.
Well, no, I can't do that because I don't know that these are parallel yet, right? That's what we're trying to show.
Is that like CP?
Ah, there it is, yeah. CPCTC, which means what? No, corresponding parts of congruent triangles are congruent. Yeah, these are corresponding parts of congruent triangles, right? So they're congruent, okay? Now we're down to the last step. Now that we know those angles are congruent, that's like saying what we've got right here, right? If I know we had two lines cut by a transversal, right? And we said that those angles were congruent. How do we know that the lines are parallel then, Abby? What do you think? Those are alternate interior angles.
Yeah.
So what's the reason that says if alternate interior angles are congruent, then the lines are parallel? Remember what that's called? Not the alternate interior angle theorem. It's the converse, yeah. Remember, it's the converses are the ones that end up with then the lines are parallel, right? Good. So we got it. Okay. So if we wanted to look at well, let me write that down. So the last step would be then MS, oops. Side MS or segment MS is parallel to segment TR by alternate interior angle converse. And we got it. Okay, make sense? If we wanted to write all that out as a proof, here's what it would look like. And this is, oops, this is, this PowerPoint's already up on the site, so if you want to just go back and look at this. So that's what was given, right? The midpoint stuff was given. We said then that these segments have to be congruent by definition of a midpoint, right? Then we said that these angles were congruent by vertical angles theorem. Then we said the left triangle and the triangle on the right are congruent by SAS. Then we said angle M is congruent to angle T by CPCTC. And the last step, then we know that the lines are parallel, the segments are parallel by alternate interior angles converse, right? It's a lot of stuff. All right, so, I think what I'll do, I think I'll just let you, I think we'll stop it there for today. And then tomorrow we'll plug in, there's one more little thing we're gonna add, I'll add that tomorrow and then let you have the rest of the day to work tomorrow. And then next week will be only, when's the end of the semester, is Thursday, I think, is that right?
Yeah.
So next week you've just got to, take the test, retake any tests, finish up assignments, etc. Okay, that'll be kind of just like a free week to just finish stuff up, yep.
Is there any practice test for that?
Yeah, I'll put a practice test up, yeah. Okay? All right, sound good? Okay.
Are you able to practice it?